Hello everyone, in this video we will learn about the process of mixing concrete and the important quality test conducted on site to ensure strong and durable concrete. Let's start. Testing of material before mixing. Before mixing concrete, it's crucial to test the raw materials to ensure they meet quality standards. Cement. For cement, we check the freshness, fineness, and storage condition. For aggregate, we check size, cleanness, and absence of impurities. And water should be clean and free from harmful substances. Testing ensures the material will produce concrete with the desired strength and durability. Measuring materials for mixing. Accurate measurement of material is key to a consistent concrete mix. Materials are measured by weight or volume depending on the method used. For best result, we use scales for weighing cement and aggregates, containers or batching plants for volume measurement. Correct measurement ensures the concrete achieves the intended properties. Now, proportioning of material for different grades. Concrete grades vary based on the mix ratio of cement, sand, and aggregate. For example, in 15 grade, 1 part of cement, 2 part of sand, and 4 part of aggregate. For M20 grade, 1 part of cement, 1.5 part of sand, and 3 parts of aggregate. And for 25 grade or above, mix ratio are designed based on strength requirements and may use trials, mixes, or design standards. Choosing the right proportion is critical for achieving the required compressive strength. Now batching, mixing process and timing. Batching is the process of combining the measured materials into a concrete mixer. Steps include adding coarse aggregate first, then adding fine aggregate, sand and cement, mixing dry material thoroughly, adding water and any chemical admixture slowly while continuing to mix. Standard mixing time is generally between 1.5 to 3 minutes in a mechanical mixture to ensure uniform consistency. Proper mixing ensures the concrete is homogeneous and workable. Adding water and admixtures. Water is added carefully to achieve the desired workability without weakening the concrete. The water-cement ratio is critical. Too much water reduces strength, too little water affects workability. Admixtures like plasticizers and retarders may be added to improve the properties such as sitting time or workability. Now sampling and site testing for concrete. Once mixed, samples are taken for testing to ensure the quality of concrete. Common site tests include slump test. In slump test, we measure the workability or consistency of fresh concrete. A cone-shaped mold is filled and lifted. The slump value indicates fluidity. Temperature test. Ensure the concrete temperature within acceptable limit for curing and strain development. Air content test. In air content test, we check for the amount of air trapped in the mix, which can affect durability. Visual inspection. In visual inspection, we check for uniformity and absence of segregation or excessive water. These tests are critical for maintaining quality control before pouring concrete. Concrete technical points. Water-cement ratio. The strength and durability of concrete mainly depend on the water-cement ratio. Lower ratio means higher strength but less workability and vice versa. Curing. Proper curing keeps concrete moist after pouring, helping it gain strength and reducing cracks. Curing should continue for at least 7 to 28 days depending on the type of structure. Concrete grades like M15, M20, M25, etc. indicates the compressive strength of concrete in Newton per mm square after 28 days of curing. Workability. Workability is how easily concrete can be mixed, placed, and finished without segregation. It is measured by slump test on site. Sitting time. Initial sitting time is when concrete starts hardening, typically 30 minutes to 1 hour. After final sitting time is when it becomes hard enough to bear load, around 6 to 8 hours. Admixtures. Chemical admixtures are added to concrete to modify properties like accelerating sitting time, increasing workability, or improving durability. Segregation and bleeding. Segregation is the separation of coarse aggregate from the mix, and bleeding is the appearance of water on the surface. Both reduce concrete quality and should be avoided. Concrete strength development. Concrete gains most of its strength in the first 28 days, but it can continue to strengthen over months or even years under proper condition. That covers the essentials of concrete mixing and quality testing on site. Proper material selection, mixing, and testing are key to strong and durable structures. If you found this video helpful, please like and subscribe for more civil engineering knowledge. Feel free to ask questions or suggest topics in the comments. Thanks for watching and see you next time.